morning to everybody. My name is Iacopo Mazzantini, and I'm working in innovation department of Enel Green Power. Uh, Welcome to this course. In the next slide, I will present application of ultra high durability concrete in geothermal application for water basin and mud basin with a holistic approach for the design. Enel is one of the biggest utility in the world. In particular, Enel Green Power is a company of Enel that manage and build and operate a renewable power plant. As Enel Green Power, we are in 29 countries and more than 43 gigawatt of capacity installed. More than 1,200 plants and 7,600 people. We are focused in all renewable type of power plant. The biggest in history is hydro, but we are growing in wind and solar, and geothermal is more or less constant in the last year, but is a good technology for us. The growing in the last 10 years, we can see that the hydro is hydro and geothermal is not growing big, but in the last year the growing is in solar and wind application. The main challenges are support growth by ensuring construction and delivery of the plant, increase of the average of the mean of the power plant, construction of power plant in remote areas, construction activities to be managed across 5 continents, continuous research and implementation of technologically advanced innovative solutions in all sites. The Enel Green Power strategy is based on the 2 pillars. One of these is innovation and the other is sustainability. The strategy pillars are principally for shared value creation, in particular for company, environment, and local community near the plants. Where we have the geothermal power plant, principally in Italy, in Tuscany, and other plants are in US and in Chile. The capacity of geothermal power plant in Green Power is 900 megawatts, and Enel Green Power is the second global energy producer from geothermal source. The asset. Here we have a few numbers related to geothermal power plant in Tuscany. They are in operation since the last century. 37 generating units and 500 wheels and 700 pipeline, more than 1,800 employees, 7.5 megawatt of net capacity, about 7 terawatt hour the annual production, and the average load factor is around 90%. 4 million of tons of CO2 avoided. The strength point are the biggest fully integrated geothermal operator, pioneer in the use of geothermal resource. We have a culture of field cultivation, basically from the reinjection as main strategy to compensate the field decline. Performance leadership, efficiency and availability of power plants, and we are a proprietary of patent technology named EMS. Geothermal power production in Italy cover about 1/3 of Tuscany energy consumption. Pilot objective. Enel Green Power had built and will operate for coronavirus 2 pilots in Tuscany. The first pilot consists in a small scale of water tank for cooling tower, about the half. While the second pilot consists in a full-scale debris tank, is a mud basin for drilling application. The main objectives are demonstrate in industrial site the behavior of ultra-high durability concrete in different configuration compared with conventional concrete. Measure corrosion in conventional solution and compare it with ultra high durability concrete behavior. Verify experimentally the progression of cracking compared to what estimated in design phase. Continuous control of strain of the structure. Study the self-healing capacity of cracked elements and support the communication and dissemination. The location of the pilot and the exposure condition. The pilot is in Chiusdino Power Plant near Siena, and the type of exposure condition is XA3 chemical attack in high aggressive environment. The A pilot is the basin for debris tank will be built near the drilling station and used during the phase of execution of new production wheel, reproducing the same operating condition. The B basin is the water tank, will already built within the area of power station in operation, and reproduce the most real operating condition possible. The pilot tank will be connected to the real tank of the power plant in order to use the stream of geothermal water. Here we have a geometry, the final design of the water basin. and you can see is divided in three small tanks. The color is related to different type of mixed design, thickness, and geometry of the basin. In particular, from the left side, we start to the traditional concrete, arriving on the right side with the blade in very small thickness. In one case of 2 centimeter, and in the other case 3 centimeter of thickness. And the different color is the additional of nano cellulose and nano alumina. Here you can see the mud basin geometry. Is the geometry like the traditional mud basin, and we have used the same mixed design for all wall, and we will use this basin when we will start the drilling operation. We are arriving to the projectual phase of this project. Here we have a table concerning the thickness class and the requirement for leakage from the normative EN 1992-3 Eurocode 2 in design of concrete structure. And in the next slide we explain better the general provision for different thickness classes with the same normative. Class 0, we can have the leakage, and growing with the growing class, we need to reduce the leakage up to the class 3 in that require to ensure the water without leakage. The allowable crack with VK1 following EN 1992-3, and the diagram show the maximum allowable crack with it as a function of ratio HD to H, which is related to ratio between the etching bending moment and the first cracking moment in cantilever wall. The moment is related on this formula. The specific provision for thickness class 2 and 3, we have taken the the relation, the select in class 2 and 3 already seen in the slide previous. To provide an adequate insurance for structure of class 2 or 3 that cracks do not pass through full with of a section, the design value of the depth of the compression zone should be at least x min calculated for the quasi-permanent combination of the action. Specific provision, another explanation of specific provisions. If the provision 7.3.1 for thickness class 1 are met, then cracks through which water flow may be expected to heal in members which are not subjected to significant changes of loading or temperature during service. In the absence of more reliable information, healing may be an assumption where the expected range of strain at the section under service condition is less than 100.5 multiply 10 at -6. If self-healing is unlikely to occur, any crack which passed through the full thickness of the section may lead the leakage, regardless of crack. Summing up, the structure at the issue was designed in order for leakage to be minimal, as focus of the pilot is on the thickness guaranteed by concrete alone, with no special measure. Class 2 was a sum in the design. In service condition, SLS, which is the most important design situation, calculations are focused on crack width and compression zone depth. Clear the structure should also possess sufficient resources in order for failure ULS to be averted. Here we have the geometry of water basin. The basin 1 is 7 meter for 7.5 meter, and reinforced concrete with the thickness of 100 millimeters. The second basin is made from with ultra high durability concrete with fibers. Thickness is in this case 60 millimeter, and in the basin 3 we use the most thickness of 30 and 20 millimeters with pillars each 100.5 millimeters. The geometry of the structure in 3D view is here. The color is related to the thickness and the mixed design, and we can can see the different from 10 centimeter up to 6 centimeter and 3 and 2 wall of ultra high durability concrete. The foundation is with traditional concrete with thickness of 30 centimeter. The materials are the reinforced concrete C2530, mechanical properties from EN 1992-11. Characteristic of cylindrical compressive strength is 25 megapascal. Average direct tensile strength 2.6 megapascal, and average indirect tensile strength in bending 3.1 megapascal, and instantaneous modules of elasticity 31 gigapascal. Ultra high durability concrete is an experimental campaign carried out at Politecnico di Milano on thin beams and deep beams, tested in 4-point bending to characterize the behavior. Here we have two diagrams for thin and deep beams done in Politecnico di Milano, and under the graph are related to the open crack and the pressure in megapascal, and from the different color we can see the experimental curve, the experimental average, and elastic perfect plastic load that in the initial part is fit very well. The experimental campaign highlights strain hardening behavior both in thin beam as well as in deep beam. Good agreement between the elastic perfectly plastic approximation. Based on the experimental results, the following properties were summed in the design. Average direct tensile strength of 5.6 megapascal, average indirect tensile strength 9.6 megapascal, and instantaneous modulus of elasticity 45 gigapascal. Preliminary design of thickness of 3 basins. The design of the wall was carried out with reference to the maximum water depth equal to 1.5 meter, using a simple design equation based on cantilever structure scheme for basin 1 and 2, A to infinite, and the rapport between A and B to go to infinite, and on slab clamped along 3 edges for basin 3, thanks to the presence of the buttresses. With the basin 1, after the calculation, we have results of 104 millimeter of thickness, and we use the in thickness of 100. In the basin 2, after the calculation, we have 59 of thickness, and we use 60. In the basin number 3, we have had from the calculation 25 of millimeter of thickness, and we choose to use the 20 and 30 millimeter of thickness. Here we have an evaluation to the stress, and the maximum tensile stress is in the center of the wall, at the foot of the wall, and in red color we have 3.05 megapascal is less than F. We can see in the compressed phase we haven't we have the minimum tensile stress. For the basin 2, we have in the same point the maximum tensile stress in red, and here we have 8.6 megapascal, and the phase in compression zone we have the minimum of the stress. In the basin 3A, we have the case before is the worst case in at the foot of the wall. You can see in red, arriving to the maximum tensile stress of 88.50 megapascal, and in the part in the compression zone we can see the minimum of the stress. And in 3B, applied on the wall of the 2 centimeter of thickness, is we are arriving on 17.4 megapascal, is more than the projectual value. Definition of SLS and ULS of the structure. In service condition, the structure is checked under water level of 1.3 meter for crack width and depth of compression zone. The ultimate limit state is assumed to take place under uncontrolled increase of the water level above the service level. The verification is carried out by means of the yield line theory by assuming the suitable collapse mechanism complying with the boundary condition and determining the corresponding maximum water level as a function of the resistance provided by the structure. In service condition, part 1. The verification of the walls was carried out with reference to the same structural scheme used in the design phase. The stresses and deformations were calculated by assuming A is the measure of large of wall, a cracked state stress distribution for reinforced concrete as per EN 1992-1. B is the height of the water level, an elastic perfectly plastic constitutive law for ultra high durability concrete. In the table we can see the A in the one and second in the first and the second basin. The measure of the A is infinite. B is 1.3 meter of the height of the water level. The rapport is infinite for both basin. The load is 13 kilonewton for square meter, and the torque, the moment, is kilonewton per meter. Each meter is 3.66 and in basin 3A for the wall of 3 centimeter of thickness with A 1.5 meter. The water level is the same. The rapport change this time 1.15 for 3A and 3B. 3B is the wall of 2 centimeter of thickness. The load is the same for all basin, and the moment is 0.67 kilonewton per meter each meter. Checks in service condition, part 2. The calculations for ultra high durability concrete basin are carried out at the sectional level by assuming place sections to remain plane and enforcing equilibrium through an iterative procedure. The resulting state of stress and strain on the section allows to determine the neutral axis depth xc and crack with mean W max equal to epsilon T max multiply T. In the table we have only the basin with ultra high durability concrete, and not is the first basin with the traditional concrete. In the basin 2 we have the moment different from the 3A and 3B, and xc is the natural axis depth, is respectively 30, 15 and 8 millimeter, the rapport between XC and H is respectively 0.5 for basin 2 and 3A and 0.42 for basin 3B. And epsilon T max per mil is 0.14 and for 3A 0.10 and for 3B 0.39. The cracked width is in micrometer is 8 for basin 2 and 8 for basin 3B. Checks for the ultimate condition. While in basin 1, 2 and 3A, the collapse under increasing water level is triggered by a single yield line at the foot of the wall, one-way behavior, global failure. In basin 3B, the most likely collapse mechanism is represented by a yield line pattern that corresponds to a local failure of the wall without involving the batteries. If we use the formula that correlate the water level in a function of lambda of the function of the water level, we have the maximum water level is 2 meter and 28 meter. That it is more than 1.3 meter is the water level in the project. Finally, we arrived at the construction photos. From the left side, we have in the first view the water basin, and we can see the wall of 2 and 3 centimeter in basin 3A and 3B, and in the last view we have the basin 1 during the construction. On the second photos, in the first view we see one wall that is maintained in position from a piece of wood and waiting the construction of battery trees and the foot. And in the third photos we see the casting of the basin number 2, I mean with the thickness of 6 centimeter, and the last is the fourth is the mixer that needed for create the mix design mounted directly in the plant near the activity, because we need to have the best quality from the concrete, and this concrete we have a difficult to transport with the traditional mixer, auto mixer. In the next one, we can see the mud basin, and from formwork in the yellow color, and in the first is after the remove the formwork, and in the second during the construction of the formwork. In the third we can see Liberato during the casting of small thickness wall, and in the third the final removing the formwork and clean the basin. Thank you for the attention, and have a good course.